Hi, I'm Deborah Vogler of Instant Insight, reporting from SEMI's ISS Conference 2012 in Half Moon Bay, California. My guest is Mark Thirsk of Linx Consulting. Welcome to the show, Mark.
Hi.
Well, my first question for you is this. Looking ahead to not only 2012, but 2013, if you can, if you are willing, what are the challenges facing materials suppliers in the semiconductor space in general as companies cope with the vagaries of the marketplace? I'm thinking of how companies have to juggle the needs of serving semiconductors, displays, HBLEDs, and solar PV.
I think the complexity is the main change. There's lots and lots of complexity. As pitches shrink, then all suppliers are struggling to keep up with the new technologies. Suppliers have made their choices about which markets to play in, and we've seen several suppliers try to get into PV. They've developed very credible product ranges, and they've really found that it's been either too much of a challenge, not enough return. So many suppliers have really shaken out whether or not they want to play. They've set up the infrastructure to compete in PV or not. HBLED is another growing market where there's still some jostling to get in. There's the supply side of that is still an interesting place. But back to semiconductors, that's a big challenge for R&D investment and really keeping up with the roadmap, which continues to move forward.
Are there any particular challenges, if you will, that need to be overcome? I mean, how are companies, if they're playing in all, let's say that you have a company that's playing in all those spaces, not maybe just one or two, how do they do the juggling?
Playing to their strengths. We see some big companies trying to play in multiple regions, or multiple segments, should I say. Everybody tries to play in every region. But they really have to prioritize their R&D dollars. If they need to do application support, there's some very, very big investments they need to make, many tens of millions of dollars in lithography equipment, for instance. So players in the patterning side have to consider whether or not they can confront that sort of cash. What's interesting is we're seeing a lot of suppliers coming into the ancillary space through collaborations with end customers and with people who have that equipment, the consortia and some of the other material suppliers, like the photoresist suppliers. So it's a matter of collaboration, of intelligent design of how you're making your application support and your R&D and prioritization. We see some companies bravely stepping away from products that they were perhaps well known for many years, and saying that they're not going to do that anymore. So very good strategic planning and good focus is the way to go to move forward.
How is materials R&D changing in terms of the financing and technical approaches that need to be used now versus just a few years ago?
Again, those equipment costs that we see coming in are changing the way people will plan their financing. The big guys are really the guys who can continue to play. It's very difficult for small companies to access the sorts of capital equipment in-house that they need to support development and support quality control. So we see collaborations with customers, we see collaborations with consortia as key there. One of the activities of Semitech that's been vital for probably the last 20 years is the Resist Test Center, which has now moved to Albany. And for anyone in the patterning space, being involved in that gives them access to state-of-the-art equipment that they just can't get access to. They couldn't even buy it if they wished. But collaboration is key, and if you can't collaborate, you have to be big to buy.
Could you discuss the EUV wafer cost effect? Now, you presented this in your presentation this morning here at the conference, and I think our viewers would find that intriguing.
Yeah, what we did was we modeled the cost of wafers with and without EUV, assuming EUV introduction was delayed. So our base case was a 2013 introduction of EUV. And the simple number that illustrates our point is we get back to a cost per square centimeter of silicon. And if EUV doesn't make it as a commercial high-volume manufacturing technology by 2017, we see a penalty of about $1.30 per square centimeter of silicon. That's made up of increased materials requirements, double patterning, increased fab footprint, increased processing requirements for CVD and etching. So there's an awful lot that comes behind that extra $1.30 per square centimeter. What that translates to is, if you look at a large foundry, they may be starting across several fabs over 100,000 wafers a month. And you multiply that out, it becomes billions of dollars of extra cost, which is a penalty for the late introduction for EUV. So it's on the cost-saving side, it's a very, very important variable for the whole cost per square inch of silicon or per square centimeter of silicon, and it applies to different device segments differently. NAND would love to have EUV next year. Logic can maybe hang on a little bit longer, but every year that EUV doesn't appear, we'll start seeing extra cost and extra complexity, perhaps the requirement for more wavelengths in fab to keep costs low. So it will be a significant cost adder if we don't have it in the repertoire.
You also had some interesting comments and calculations with respect to 450 millimeter manufacturing.
Yeah, what we did was we thought about how much silicon we're going to have to process to keep the world demand on a relatively conservative basis. And current projections say around 2018 we're going to start seeing some 450 fabs start to produce, which is a stretch. We've only got a few years to really pull that together. The amazing statistic is, if we don't have the 450 fabs, we're going to have to build a lot more 300 millimeter fabs, and the logistics change to supply them, the engineering to put them up, the space, the water, just the requirement in personnel is huge. So really on a capability basis, this industry needs to add capacity in 450 about 2018 when it's being planned to come in. So it is very important to move ahead with 450 millimeter. The materials the equipment requirement to support it will probably stay roughly at the same level it is today at 300. We anticipate some reduction in materials requirement, but that's more than offset by the complexity of the device design. So there's still plenty of market for the materials guys to develop.
And now, changing topics completely here, you made an interesting observation about PV, saying that it can't stand on its own it needs subsidies. But what about if legacy energy sources weren't subsidized then? Could it stand on its own?
It's an interesting question. There's a segment of PV which today is viable without subsidy. It's small. It's probably 5 or 10% of the overall market. If the subsidies for other forms of power were removed or reduced, that would raise the baseline, and more of the PV industry would be sustainable without subsidy. The macroeconomic effects are really the barriers there. You know, if consumers, both industrial and private consumers, see power costs rise around the world, that certainly will be an impact on the global economy. So it's unlikely to happen, but definitely the baseline that PV competes against is the grid costs, and pretty much all over the world, grid costs are subsidized to some extent. So removing those subsidies would put PV on a much more competitive basis, but probably not completely cheaper than grid yet. So it's not the answer.
All right. Well, thank you very much for being my guest.
Great pleasure. Thank you very much.